So we've now talked about three of the core components of visualization designs: the data we're using, the tasks we complete to generate knowledge with that data, and the visual channels we use to assemble our marks. So the next question becomes, how do we put all of these pieces together? Well, there are a variety of different design techniques, approaches, and methods that we can use. I'm going to show you a few of the most common methods that we see within visualization design for doing what is called user-centered design. The basic idea is that we want to put together all of these different pieces in a way that optimizes for our target user's needs. When we're doing project management for visualization design, as I mentioned, I think one of the most productive ways to do this is to engage in what's called the user-centered design process. Essentially, we are working directly with our stakeholders, or the people that we are designing for. And we're working with them to figure out what data they have, which relates to this idea of data abstraction, what questions they have, which results to the last lesson's topic of task analysis and elicitation. And then we want to figure out what are our strategies from getting from data and task to a concrete deliverable. And so this will take us through the prototyping life cycle. And I'm going to, over the course of this lesson, talk about two different techniques for going from data to deliverable. One of these is called the 5 design sheets methodology. It's a sketch-based methodology that's intended to very quickly get you as a developer and your stakeholder on the same page. And we'll also talk about a technique called the design studies methodology, which is a deeper, more longitudinal effort where you're trying to essentially iterate with the stakeholder in a participatory design process to really design a tool that works explicitly for the problem they're working with. The core idea underlying all of these methodologies, however, is how do we build a good prototype? So the idea of prototyping is just getting something that we can iterate on. It can be as simple as a mock-up of a target output or even a fully fleshed out functioning system. But the basic idea behind prototyping is that we want to create something that gives us concrete feedback and that we can use to readily get the kinds of information that we need to ensure that our solution will actually work in the way our users need it to. So when we prototype, we're looking to foster what's called a bias towards action. We want to create and critique as frequently as possible to build around a central challenge. So many ideas work fabulously in theory, but as soon as you start putting them together, you can see all of the holes in the approach. So by engaging in different levels of prototyping, we hope to get to these different holes earlier and proactively address them. Prototypes occur at 2 primary levels. We call these the low fidelity and high fidelity levels of prototyping. Low fidelity levels of prototyping are essentially just developing simple, low-tech, conceptual mock-ups. And the idea here is that if we sketch something out, or we draw it on a whiteboard, or we draw it on a piece of paper, it's very low cost. We can get the basic idea out, get a sense of what the idea might be, and have something visual and concrete to iterate with people over. And it's something that's low cost to you. That particular idea didn't work out? Toss the sheet of paper, go back to the drawing board. Low fidelity prototypes are a great way to gather early feedback, but they don't necessarily allow us to probe at more sophisticated levels of user interaction, such as what happens when we get real data in, what happens when people are actually working with the tool, how do we understand how different pieces of our visualization might fit together meaningfully. This is where we move to that idea of high fidelity prototyping. When we've mocked up our low fidelity prototype, we've figured out what it is we want to generate and build, we can use our high fidelity prototypes to create refined and functional representations that fairly closely resemble the finished project, so you can get final feedback and really create a deliverable that works well for you. So you can think about the low fidelity prototype as something like this set of sketches we see here in the lower left, and as we understand the data, as we understand the problem space, we can flesh that out more into something like we see over here on the right. One of the tricks here that I want to encourage is that as developers and as data scientists, we often just want to jump right into the code. The code gives us pretty things, it lets us use real data, it lets us build functional things. The other thing that coding is incredibly slow compared to something like sketching something out on a whiteboard. So we can use sketching to create actually both low and high fidelity prototypes, but we're going to most reliably turn to sketching when we're creating these first ideas, these low fidelity prototypes. And one methodology that we have that allows us to use sketching to generate these mock-ups and set ourselves up for success when we're creating our higher fidelity prototypes is a technique called the 5 design sheets, or FDS. With FDS, our basic goal is we want to rapidly work with a stakeholder to create a preliminary visualization design. And the way we're going to do this is through just working with 5 sheets of paper or 5 whiteboards, if that's your preference, to really get onto paper what are our ideas, what do we think is going to work, and what are the constraints of the problem that we're working under. So you can see an overview of these sheets here on the right, and the depth of the color of the sheet represents the maturity of the idea that's represented in that sheet. So we start off in sheet 1 with just brainstorming, coming up with as many ideas about our topic as we can, including ideas about the data, about the tasks, about the interactions, the marks, the designs, and then we organize those ideas in meaningful ways that allow us to figure out which of these directions is most promising. From there, we have a series of iteration sheets where we're going to create low-fidelity prototypes of our various designs and track the conversations that emerge around the development of these prototypes. Our final sheet is realization. Essentially, what we're doing at the realization phase is we're analyzing our final design to figure out what is it going to take to make this system that I have on paper, this low-fidelity prototype, into a reality, into a high-fidelity prototype that I can give to my stakeholders and really let them experiment with and provide feedback on. So just to deconstruct these sheets in detail and what goes into them, our first sheet, our brainstorming, is really the most loosely defined sheet. What we're doing here is we're sketching out as many ideas as possible. We're getting as much information about what are the possible tasks, what's the possible data, what are the possible designs, all into one place. And once we have that brainstorming sheet where we're just basically designing and ideating without judgment, we can pause and filter out and select the most promising ideas and group together related ideas, ideas that might share a common function or work towards a common task. Once we've categorized our ideas, we can combine them and refine the set of the best or best sets of options to try to figure out what does our low fidelity prototype truly look like. And this iteration is going to be done in sheets 2 through 4. So we're going to, generally speaking, do this 3 times. 3 turns out to be a pretty solid number for this. I don't know if it's human bias or just something about the way that the space of design works, but 3 iteration sheets turns out to be pretty good. And the basic idea behind an iteration sheet is that we have different ways we're going to probe the idea that we've pulled from our brainstorming sheet. So we're going to look at what's an overview of the general component we're iterating on, sketch out then the details or the focused elements of one of those components, and we're going to talk about and outline the operations or interactions involved with that component. Think about this as like, what kinds of tasks will people need to do and how will they do them? Then moving into discussion and reflection, keeping track of what's working here, what's not, what might require additional design, additional thought, or complementary designs. So this sheet essentially is intended to help us keep track of what is going on in our ideation as we start to flesh out those most promising designs. And we will typically, as I mentioned, do this 3 times, with each sheet describing either a new potential alternative approach, or if we're doing something like designing a dashboard tool or a multi-view system, let's say we're designing something with overview plus detail interactions, then we might want to think about mocking up each component of the visualization as its own separate sheet. So the final sheet, this 5th design sheet, is the realization sheet. Its layout actually takes a very similar flavor to the iteration. We want an overview of the full visualization tool we intend to prototype, and then sketch out relevant elements in detail. We'll also want to, when we talk about the operations, think about what are the interactions between components and how do they serve the broader set of tasks and user needs that we have in our visualization. Finally, in place of the discussion and reflection, this is a good point to pause and think about, what will it actually take to build this thing? What kinds of algorithms do we need to implement? What kinds of resources do we have? What kinds of timetables might we need? What kinds of hardware do we need to develop for? These kinds of questions are questions that might feel tangential to the visual design, but they turn out to be absolutely critical for implementing the visualization and for ensuring that the visual design that you've created on paper is actually something you can implement in your target media. So this is a really, really critical step to ensure that there's agreement across all of your users of what is it going to take to make this thing a reality. And does this need to be a desktop application or a web-based application? How do we get the data back and forth between people? What kinds of privacy concerns might we have? Is this something that should be an open source tool, or is this something that should be just publicly available on the web? These are the kinds of conversations that often get swept under the rug when you get really excited about cool designs or really potentially impactful implementations, but they're the kinds of conversations you need to have in order for a project to be successful. So I'd like to encourage you to engage in a hands-on activity where you're using the 5 design sheet methodology to redesign a target dashboard. I'm going to encourage you to just do this with 3 design sheets, so you're welcome to use all 5 if you want, just cutting down that iteration to 1 sheet instead of 3. But what I'd like you to do is find a dashboard online that's intended to communicate to the public. So this allows you to envision yourself as one of the target users. Places like Google Analytics or government agencies like the CDC or WHO, or even the university's own dashboards might be good places to start. Once you've found the dashboard you're interested in, use FDS to try to prototype a solution that you feel will improve the dashboard for the kinds of tasks that you would need to use that data for.